Good afternoon, ladies and gentlemen. My name is Vlastimir Černý and I'm IT director of one of the largest faculty hospitals in Czech Republic. So my presentation is going to be about the IoT project which we just recently did in our hospital. But at the beginning, I would like to introduce the hospital so you have an idea what kind of hospital we are and how huge the whole project might be. So the hospital is 43 specialized departments. We have 6,500 employees. And we have 1 million and 1.7 million outpatients episodes during a year. And also we have 65,000 inpatient episodes. So we are pretty huge, and we just decided a couple of years ago that what we do, that we'll start using cloud technologies, and one of the part of the cloud technologies which we are using is obviously the IoT platform, where we are focusing mainly in the hospital is how to use artificial intelligence in terms of provided care to the patients. So. Well, we didn't have, so our question wasn't if we should go this way, but we asked ourselves the question if it's the right time. And 3 years ago we said, okay, it's the right time. So we moved the hospital to the cloud, most of the applications, and we have a strategy right now where all the projects which we do, we go cloud first strategy. If there is no obstacle, then we go this way. And we started to use the platform which came with the Azure services from Microsoft. So what we use is artificial intelligence in the cancer treatment, and also we started a project where we try to find out a solution for the nuclear medicine. But what we also do, that we are looking how to improve our processes, and one of the processes which we are trying to find out solution was how to measure temperatures and other things within the hospital. For your information, we roughly right now running 2,500 sensors within the hospital. So we are looking for the platform where we can integrate all those sensors. So the project which we started last October was how to make a base for future integration of any other sensors which we might have in the hospital, or how to integrate existing sensors. We are looking for a solution which will allow us reuse the platform, and also where it would be easy integration, automation, and we might be able to analyze the data. So goal of the project, as I said, was how to set up the base. Then we wanted to be sure that it will be open and universal. And also what we try to achieve was that we would like to have knowledge within the hospital, how to maintain, and also how to extend the solution. The realization and outputs from the projects were that we choose two departments where we integrated, or we didn't integrate it. We set up the new sensor sensors where we were measuring temperatures, mainly in the freezers and the refrigerators. So for us, the goal was to prove it, that we are able to do it, that we are able to do it quickly. And here you see what we achieved. We used the platform as I was mentioning at the beginning, which is based on the Microsoft Azure. And so you can see how it looks like, but real implementation is here. So you can see that we are measuring mainly the laboratory, 2 laboratories. The reason for that we have very expensive drugs and materials, and we have to be in compliance with the regulatory requirements. What we are looking for was also how to do it without necessity to penetrate the equipment. So we were looking for a wireless solution. So as you can see, we have a wireless sensors within the equipment. The outcome for us were dashboards. We are using Microsoft Power BI presentation platform. So what we do, we are collecting the data from the sensors. We analyze them within the Azure environment, and we have a presentation through the dashboards. Also, what we have automatization, so we are able to notify people that there are any anomalies within the range of the measured temperatures. So I think you will see the live presentation of the dashboard, so I'll skip it. And at the end, I have one slide why we choose the IQRF Alliance for a solution. So for us, as I said, we are looking for the simple physical installation. That was one of the reasons why we choose that. Also, we are looking for some kind of high availability. So we are very happy with the mesh network and sensor communications with the gateways. Also, as I mentioned, we are looking for an open environment. So that was also achieved. And we are looking for the system which is cloud ready. So we are able to implement it within the cloud. So that's basically my presentation. It was very, very quick. And I'm ending up with the situation with the hospital. So this is how it looks like when we interact with the patient. So that situation from our inpatient laboratory. Okay, thank you.
Thank you. Thank you very much. Yeah, thanks. Can we get to the second presentation now of this part? Thanks. So pretty much, I think it was maybe September when we got a call, or October when we got the call from the hospital that if we can really deliver actually this project. So and again, like there wasn't a company in the alliance like that would like just deliver it as a whole. So that was the role for the IQRF Solutions again, right? So again, like we try to understand what are the needs in here, and it was really about like the message that I understood was like we want to do as much as possible ourselves, and definitely we have to learn it, but we want to have a flexibility in matter of end devices. We want to have the flexibility in gateways, and we will do our own clouds and this part. So we put together the team like JoTio as the guys providing the architecture and actually doing the deployment. Rehive Tech, we use their gateway and also the remote management system. So if there are troubles, let's say with the connectivity, we can fix it. we use the sensors for IQ Home and also the plug from NetSeal. So you see that this is quite a, let's say, simple, small pilot project, but even that, like maybe 5-6 companies are involved, the customer and so on. So even such a small thing could be quite complex. So now I would like to ask Vojta to give us, let's say, his introduction of how we approach the whole project from the architecture perspective and also from deployment perspective.
Thank you, Simon. Hi. One more time, this slide. I am from JoTio, and in this project, this General University Hospital in this Prague, we are in a consultation role because IQRF is a technology, is a very low level, and it's not so easy to understand everything, every procedure. And we designed this architecture on the start. On the left-hand side, you can see some IQRF networks. There is sensors in the fridge. And main point of this architecture is IQRF daemon. It's a IQRF gateway where we run IQRF daemon application, and this software provide connection to the two sides. One side is a pixel management portal, and other side is Microsoft Azure. Microsoft Azure is a main payload portal, but Pixel is very important for us. We can help them solve any problem. On this picture, you can see how looks when you install device. For example, on the left-hand side, you can see device in the fridge, and up this picture, there is 24 devices, and it's a little problem because you must solve problem how to open these devices. There is my colleague, and we have a lot of challenges. For example, first big challenge, preparation of this project. We must open every boxes more times, set up, push button, and so on. It's a long time to preparation this project. Second problem is that we use a non-interoperable device. This is IQ Home sensors. It works, but we must solve problem how to use this device in interoperable network. Sometimes we solve problem with internet connectivity. As presentation before, you can see LoRa network maybe can help because we solve problem when you don't have connectivity to the gateway, you cannot do anything. Internet connectivity is very, very important. And new needs for us is think about metadata, because we solve problem. Where is this device? How old is this? And it's a lot of information about it. And next important things is calibration, because if you have metadata, it's nice, but you must know, for example, how old your device is, because for example, in the hospital, we must every year make a calibration, and we solve this problem together with hospital. And we expected JoTio hardware because this hardware can solve a lot of these problems, for example, calibration and so on. And this hardware is very simple to deploy because we are using interoperable smart connect and so on. Thank you. And next, please.
Yeah, okay, thanks. Wojciech, you can sit down. Now we should see the real data from Azure, I guess. So we have here Michal Marushan from Microsoft, who's supporting the hospital.
So, yeah. Hello, everybody. I'm Michal Marushan, and I had a pleasure basically to work on this project together with two really clever teams, both from the hospital IT and then partner JoTio. And we kind of come up with the architecture which is for you when you get the data from the sensors and when you put it somewhere, which happened to be Microsoft Azure. So how does actually in the Microsoft Azure looks like the environment? And just very briefly, speaking about the architecture, not sure if this one, yeah, is working. So as you can see, there is just a few components, right, really, because on the far left-hand side, there is this gateways which are delivering the data into something what we call Azure IoT Hub, which is basically another gateway in a cloud where you can collect the data and you can really scale it up and then work with the data afterwards. So what we do with the data afterwards is we are running a Stream Analytics job, which is another service, another platform as a service in Azure, which allows you to work with the data on basically SQL-like language. So you just can aggregate the data, you can filter it out, you can find suspicious places in there and things like that. Afterwards, we are using this processed data in a real-time manner. We are pushing the data to the Power BI report. And also we are checking some interesting things in the data, and if anything happens, we have a Logic House, which is a service which can send you an email based on some event occurring in the real-time data stream. And of course, we are using some batch layer in terms of loading data into some database for later purposes, for retraining or for some audit of the data and so on. So now I would like to ask you for a switch to the computer, which is on HDMI. And like to show you how it looks like from the, let's say, receiving data perspective. Okay. So this is as you've seen in the previous presentation. This is the report that is the ultimate end user experience with the solution. You can see that there's a couple of things from the beginning, some averages and minimums and maximums of different sensors. You can see there the real data from the different places around the hospital. You can see that this report basically refreshes almost 20 minutes ago. So probably we will happen to see any other refresh. So the only reason why we don't see any charts moving or lines moving is because of the fact that we are uploading data once in every 20 minutes. So we have a 20-minute window for uploading the data. And as you can see, there is immediately on this really let's say operational report, you can really see some interesting things. So basically, if you can watch on this particle line here, you can see there is a big up in the temperature. If you can take a look on the actual value, it's a refrigerator, or in fact it's freezing box. So it definitely doesn't or cannot be in this such a high temperature range. So you can see immediately from the dashboard that we collected some data. Probably it happens during the night or during a couple of days before, like exactly on 27th of March. And then after that, the sensors claims that the temperature in this refrigerator box or freezing box is around 23 Celsius, which is definitely more than freezer box should be. So you can take some action. Actually, it happened that I think that we just take our particle sensor and put it in a different place. So that's why we didn't match correctly the metadata. But you can see that also this kind of reports can reveal such things like misplacing of the sensors and things like that. Okay, can you put it back to the? And in the very end of my short talk, I would like to present the, let's say, to-be architecture, which let's say is part of kind of a project V2 or phase 2, and we would like to, let's say, incorporate more intelligence into the system, meaning that we will actually use machine learning techniques to do the predictive maintenance on some other devices like power plugs, to, let's say, capture if the device connected to the plug is going to malfunction or have some issues. So this is, let's say, one of the, let's say, next goal is to employ this machine learning or intelligence on the sensory data to get better predictions on what happened next and what could be the possible outcome of it. And obviously we are aiming for incorporating more and more sensors from different, let's say, areas, the temperature, humidity, other values to capture, and I hope that we will succeed even in this one. Okay, questions?
Thank you. So, just a short chat about this. So, Mr. Cheney, actually, like this is just a very first small project, I would say, right? Like a pilot. So what else would you like to, let's say, get under control in the hospital, or what would be the interesting part where you want to, let's say, scale up this project?
Well, it was mentioned here several times. What we are looking for is to integrate more sensors, different types. So we are looking for example, how to measure quality of the environment on the our clinic where we treat kids, or where are long-term patients. So that's one thing. We are looking also that we would like to, because what we try to achieve to build the base. So one thing is monitoring, but what we are looking for is how to use it in, for example, more AI scenarios. Right. So how to measure, how to include face recognition, queue management in our pharmacies. So we are looking for different ways how to use it, and also we are looking how to integrate utilization of very expensive equipment as well. So if we are able to measure power consumption, then we are able to measure how we utilize those equipments.
All right. Again, like a call to the audience. Like we have here a project. We need like a. Yeah, there is a question. Thank you. And the guy is not from Czech Republic. Yeah, Norway. Pretty good.
A freezer is a very bad environment for a radio transmitter. So what kind of range did you see on the sensors inside a freezer or a refrigerator? The distance?
Yes, thank you for the question. Yes, freezer is metal, but we are using IQRF technology and we are using mesh technology. And it's a very, very good point for this technology, because exactly this solves mesh technology. Because if you have each fridge have repeater, we can have mass network, and it's easy to put, for example, one repeater in the room, and if you need to transmit data for few meters, it's no problem for this technology and these frequencies. And it's very, very nice usage for mesh network. For example, yes, this.
In general, I think there are like tens of meters out of the freezer. It's just not a problem, right? So actually, what we use is this approach that we put the whole network on sleep. We are collecting the data every 20 minutes, I believe, right? So the network is really sleeping and in very, very low power consumption. It wakes up. We collect the data with FRC, maybe 1 or 2 waves, and we put it on sleep again. So it's like 90.9 something of the time the network is sleeping. And yeah, the ranges are just fine. Currently we have maybe 2 free gateways out there.
3 gateways.
3 gateways, covering 25 devices. And like you should really see the hospital. It's spread out all over the place, you know. So okay, so any other questions? Like that was very promising. Okay, thank you guys.
Hi, Dennis from ION. So we are right here. We are in a specific environmental, so hospital. What about the data privacy? So you gave us an outlook towards face recognition, for instance. What do you want to achieve with face recognition?
Well, what we want to achieve is simple. So one thing is what we are able to achieve is we will recognize if it's a female or male. We can recognize the age of the people, and also we can recognize what is their mood. What is their mood? So what we would like to achieve, that they will stay, for example, in our pharmacy, so they don't go away. So we are trying to measure the queue length, and also we would like to target them with the specific ads. So, for example, if I know that you are a male, then I'm not going to show you on the monitors ads which are focused on females. That's one thing. Then also, maybe I can tell it, we are also trying to, we are in the phase where we would like to implement jak se jmenuje ten robot? Ne, robota. Jsem zapomněl to jméno. Sorry? So it's a robot. We would like to have a robot in entrance of the hospital, so it will communicate with the people. So if we recognize that it's a kid, then we can customize the interaction with the kid, and it will be different than if it's an adult. So for this type of the integration, also we would like to use face recognition.
Okay, so in this case, it's more like an edge face recognition, or
yes.
AI like...
Maybe on top of this question, like privacy, we are definitely heading for incorporating something we call IoT edge processing. So that's what you mentioned. So all these services can be containerized in Dockers and run on specific device. So no pictures, no images are sent back to cloud. Only the IDs, particular what has been found and so on. So that's how we deal with privacy so far.
Thanks.
Thank you. There is another question from Spain.
Thank you so much for the explanation on the case. I have two questions. First of all is regarding the architecture you show. There is a kind of part that you say IoT hub. What is exactly that? This is the Azure, or is a device in the middle between gateways and sensors and all the data systems? And the second question, how do you connect? What is the technology you are using for connecting gateways to the IoT hub? I mean, is cellular, LoRaWAN, or what is the technology you are using on that?
So first of all, IoT Hub is a service inside of Azure, so it's not the real, let's say, hardware somewhere. It's sitting in Azure and it's PaaS service, so you just only configure things like how big is it, how many messages you would like to receive and things like that. So it's a service inside of Azure, and we are connecting from the devices. We actually support 3 protocols in terms of MQTT, MQP, and HTTP. So basically, we are connecting through HTTP in our case, right? HTTPS. MQTT. Okay. So MQTT is the protocol which is connecting the gateways to the IoT hub.
Any other questions? Yeah, there. Oh, I will run there. The first Czech guy, incredible. Thank you, Snanda. Thank you very much.
Okay, no worries. Okay, no. Just a short question, because you mentioned that you measure a lot of physical parameters, let's say. So how do you apply the context? Because you mentioned that you use some, let's say, machine learning. So measure the physical information, it's one story, and get some machine learning and apply some context for the data, it's different story. So how you get the context for the data, because you need to tell the AI, this is wrong, this is good, this should be different.
Yep, this is a very good question, thank you for that. So basically we happen to also, besides Azure, we also deal with data on a daily basis. So we kind of look into the machine learning on a daily basis, and typical machine learning process is like we need to learn on the data. So we need to have, I would not say massive amounts of data, but some data in history and past which are labeled, kind of, and this is the thing that happens, or this is the thing that happens and it's correct, and this is false, and things like that. And we will learn on top of those, and then we are able to predict. That's basically the, let's say, failure one or no. If you would like to predict some the future values of particle metrics, so happens to be forecasting. So there's other methods how to do it, and you don't need to, let's say, label the data before, because you see the trends and you see the seasonalities and things like that. And if we are talking about the predictive maintenance and getting the data if basically some hardware or environment will fall or will have some serious defect, you can also apply some unsupervised learning methods for anomaly detection, for example. So if you see any different, behavior of the device which doesn't behave like that in the previews and history, then we can, let's say, raise some alert and on top of that take some action.
Maybe, and you can combine sensors. For example, we combine JoTio power plug, and we measure power, voltage, current, and we measure temperature in the fridge. And we can combine this together, and we know, oh, there is problem because fridge is on, everything is okay, but it don't work, and temperature go up. And for example, if we measure that we have open or closed door, we can recognize, yes, there is problem because the door is open, and we can find where is problem.
Great. Any other question? No. Okay. Thank you, guys. Thanks a lot.